Hey, here we go. This is going to be first video for chapter 10. It's measures of center and percentiles. So this is a dive into statistics and data analysis. This can be in large part review from pre-algebra, but we're going to kind of make sure that it's comfortable and familiar and easy for you guys to use and talk about. So two different kinds of data. One is qualitative data and one is quantitative data. So qualitative data is things that you can go collect, but they don't have a numerical component. So for example, if you ask people what their favorite color is, you can organize the data, you can make charts and graphs about it, but it's non-numerical. Quantitative data, on the other hand, is information that you collect that has a numerical component. So you could ask them, how much do they weigh? There's going to be a numerical value. You could ask them, how tall are they? There's a numerical value. You could ask them how much money they have. Again, a numerical value. So when we collect quantitative data where there's numerical values, we can kind of crunch that data by finding averages for an entire group. If someone says, what's the average favorite color of everybody in this room? You're like, well, I don't know. That doesn't even make sense. But if I said, what's the average height of everybody in this room? It's like, okay, cool, I can figure that out. So when we say what is the average, what we're asking for is kind of what is the center value. It's either called a measure of center or a central tendency. And there's lots of different ways that you could take an average, depending on what you're focusing on. So we're gonna look at three of the most common ways to take an average, and each has its own name. So the first one is called the mean. To find the mean of a set of data, you add up all the values and then you divide by how many you had. This is definitely the most commonly meant average. So if you don't say find the mean, you just say find the average. We almost always mean find the mean. Add them up and divide by how many values you had. The other two are called median and mode. So median is when you put all the numbers in order and you pick the one that's right in the middle. Okay. If it's an even number of values, there's going to be two in the middle. Then you take the mean average of those two that are in the middle, which is halfway between them. But in general, you're looking at like what's right in the middle, and that's the median. And then and a way to remember this, none of you probably drive yet, but once you do drive, the center of the road is called the median. It's like right in the center between the two lanes going, one lane going forward, one lane going the other direction. So the median of the road is in the middle. So that helps you remember the median is the number right in the middle. And then mode is like most often, and mode rhymes with most. So that's hopefully easy to remember. There can be multiple modes. If you have a big data set, it might be a tie for which one comes up the most. So there could be multiple modes. And if every number shows up the same number of times, then there is no mode at all. Nothing was the most common. So mean, median, and mode are very commonly given measures of center or central tendencies for a set of data. Okay, let's use this information in an example. So say we measure the heights of all the kids in our class, and we get these values, 60, 69, et cetera, et cetera. So to find these three averages, what we're going to want to do is put them in order so that way we can see what's in the middle. So go through and find the lowest one. What I like to do is just like underline it wrong button. Underline it or cross it off when you do it. So 58 is my first one. Scan through, find the next one. I got a 60 and then another 60. So we'll go 60, 60. Then keep going. I got a 61 and then a 62. 61, 62, then I got a 64, then I've got a 65, then I've got a 69, 69, 69. So three of these at the end. That's 5'9", by the way. Okay. As you underline them, you can easily make sure you didn't miss any. If you don't underline any, it's almost really hard to keep track. You can also count how many you had. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to make sure you didn't miss any. Now to find the one in the middle, that's kind of the easiest. So we just go 1, 2, 3, 4, 5. So the middle is right here. So what's the middle between 62 and 64? It's 63. So the median, once you put them in order, the median is the easiest. The median is 63. The mode, to get the mode, we just have to see which one occurs the most often. And you can see 60 shows up twice and 69 shows up 3 times. So the mode is 69. And then the mean, to get the mean, it's actually the most work. We're going to need to add up all these values and get an average. Now, we know it's going to be somewhere in the middle, right? Like that's obvious and it makes sense. We've got a little bit more bigger values than smaller values. So we expect it to be, I don't know, somewhere probably close to 63, to be honest. This is spread out kind of evenly. But just whip out a calculator like I have here, add them up. I'll try to go fast to save your time. plus 60, plus 60, plus 61, plus 62, plus 64, plus 65, plus 69 3 times. So I got 637 when I added them all up. And we count there's 10 numbers, so I divide by 10, and I got 63.7. 63.7. So we got these three values. The question also asks us, do we think any one of them is best and why? Comment on the idea of reporting a single number to represent a whole set of data. So if you want to stop and think about it, like it's unreasonable to just report a height of every single person in class every time someone says, hey, how tall are these people? But also like, are these actually capturing the height? I don't know. So I want you to think about if you drew these on a graph, right? And we had height here, and we plotted them, it'd be like, okay, 58, 60, 60, 61, 62, 64, 65, 66, and then 69, 69, 69. So if you kind of see that, like visually, you can see all these height values. Is reporting a value of 69 representing well the entire class? Like I would say probably not. Just because it showed up the most often, it was actually at the extreme end. So yes, we have a lot of tall people in this class, but that's nothing to do with the average over the spectrum. So, you know, the average is probably right in the middle here. So both 63 and 63.7 kind of capture that. But any set of data is going to have kind of a range. So one thing to think about is, do the averages accurately capture the data? Well, this is all spread out. It wasn't like everybody was the same height. There was some people that were shorter. There was some people that were taller. So giving one center value doesn't necessarily tell you everything about it. If you have a lot of data that's clustered or spread out evenly around a central starting point, it's often called a bell-shaped curve like this. Then the average right here in the middle of whatever it is often a good thing to report. And you only have a little bit of people that are way above average and a little bit of people that are way below average. And the majority of people are average or close to average. So this is called a normal distribution or a bell-shaped curve. It's in the science behind a lot of standardized testing sort of stuff. And you'll learn more about this later on as you advance through mathematics. If you're interested in learning more about it, certainly come talk to me and I can do so. But for now, we're just focusing on these three averages, mean, median, and mode. And now we'll go on to the last slide, which is percentiles. And this one just kind of introducing this idea. Percentiles are actually pretty simple. Just like with finding the middle number, you have to put them all in order. So let's just read this together. Percentile is a measure that is often used to report test data such as standardized test scores. Percentiles measure rank from the bottom and tell us what percentage of the scores were below a given score. The lowest score is the first percentile, and the highest score is the 99th percentile. There is no 0 or 100th. Honestly, I actually kind of take issue with this. I don't know why there wouldn't be no 0 percentile. If you scored the very bottom, then there was 0 people below you. But that's my own personal issue aside. So how do you do it? Put the data in order, count up how many values were less than whichever one you are looking at, and then divide that by how many numbers there are overall, and then convert it to a percent. This last step, multiply it by 100, that's just converting it from a decimal to a percent. So as an example, my video camera is in the way a little bit, guys. Sorry about that. There we go. So if you scored in the 74th percentile, what that means is it means you did better than or scored higher than 74% of the people that were taking whatever that test was. So the best score you can get is 99th percentile because that means you were better than 99% of all the people taken. It seems like we're always rounding to the nearest whole number for these percentiles. You're not going to see like I was in like the 73.2 percentile, even though you could theoretically do that if you had a big enough set of numbers. So anyways, let me know if you have questions in class, and I look forward to working on this with you guys. Take care.